All right, so I want to take a second to review when just generally finding domain and range of exponential versus log functions that we talked about a couple days ago. So I have technically three functions graphed. To the right, this is what you would put in Desmos. The first one is y equals 2 to the x. That's in blue, but I'll write that here. So that's just our general exponential function that we've been talking about for a couple weeks. And then I also have y equals log base 2 of x, which we've been talking about now, transitioning to logarithmic equations. And what did we say about these two functions? We said they were inverses of each other. One visual way to say that, you can see I have the line y equals x graphed. Also with those, they're reflections of each other. And then also, if you remember, their domain and range should be opposites of each other. So let's just do a little review here. If I'm looking at my blue function, y equals 2 to the x, what's the domain? Well, that's from left to right. Right? Like, are there any restrictions? We would say no. So we would either say all real numbers, or we're used to writing in interval notation, negative infinity to infinity. What's the range? Well, we've talked about, and it was mentioned a couple days ago, that there is a horizontal asymptote, right? And it's this line right here. We kind of do a dotted line there. And your exponential won't reach those unless you've won't cross that line unless we've shifted the graph in some way, shape, or form. So the way we would describe that range, we use y. It's not going to reach 0, and it's going to be above that, right? We go up, so y is greater than 0. What about the log function? Well, the domain this time is cut off because we have what we're going to call a vertical asymptote. Hopefully that makes sense. The HA horizontal, VA vertical asymptote. And so your x's won't go past this line. In fact, they'll be greater than 0, and they won't actually reach that asymptote. So domain, we use x, and x will always be greater than 0. All right, and hopefully you're noticing these are flip-flops of each other, just with x versus y. And also, what about range? Well, I'm hoping you notice these should be flip-flops as well, but as you can see, the log function will go up forever and down forever other than meeting that asymptote for the domain. So your range will be all real numbers. So the thing I want to focus on is, excuse my dog, the domain here for log functions, because once we get into the equations, we're going to have to talk more about those. So anytime you're taking the log base b of something here, what must be true? Well, whatever is inside here has to be greater than 0. And we've seen that from notes the past couple days as well. Why? Because if you take the log of 0 or you take the log of a negative number, right, we will get an error on our calculator. So we have to keep this in mind whenever we start looking at logarithmic equations. So I might ask you something like this. Find the domain. To find the domain restrictions of a log equation, find the domain of each log. I'll describe that in a second. Find the intersection between them, which means the most restricted region. Just a check is that make sure when you plug in your solution, you're never taking the log of 0 or a negative number. So let's say I give you this equation. Hopefully you're cool that this is an equation. It involves logs. There's logs on both sides. We'll get to how we solve this in a second. But what are domain restrictions? Remember, domain are just x that I'm going to be worrying about here. So what do I do? Well, first thing is you want to find the log of each part, because I could graph each of these individually, right? So I'd have a log over here, and I'd have a log over here. So let's deal with the first one, x plus 2. What do I need to know about that x plus 2? It actually does not matter what base this is. It could literally be anything. But we know that that x plus 2 has to be greater than 0. Well, you could solve pretty easily here, which means x has to be greater than a negative 2 just by subtracting the 2 over. All right. What about this one? X minus 3 has to be greater than 0, so x has to be greater than 3. So these are the domain restrictions for both of those logs, but how do I determine my overall domain restriction for the entire equation? Well, you look at the most restricted region from both of them. So let's say I was looking at a graph here, okay? Think about where x is greater than 3. So let's say here's 3, right? It'd be everything here and this way, right? What about negative 2? Well, negative 2 is actually over here. It'd be everything here and this way. But there's this region here right in the middle where your domain isn't satisfied for that right-hand side, right? So our most restricted region would be everything over here, right? So you would use this x is greater than 3 as your overall domain restriction for this equation, because the one I'm underlining here does not restrict that region right here that I circled. So there's some values there that will work for that left-hand side that won't work for that right-hand side. And we'll see that kind of in practice here. So properties of logs to review. We have used this a ton. We should know how to go from log form to exponential form. This should not be a big surprise to us, right? And we're going to use that to solve log equations. We'll do some examples here, but I want to introduce a new property. This property is very, very, very similar to the one-to-one property for exponentials. In fact, just to remind you, if I have a to the x equals a to the y, right? If I have the same base, I just set my exponents equal to each other. So that's the same here. If I am taking the same log base on each side, I can take what those logs are and set them equal to each other. So it's pretty simple to solve from here. You just have to make sure that your answers fit in the domain restriction that you now know about. All right, so here are our first two examples. Let's see. Okay. Solve each equation for the variable. Check your solution to make sure it is not in the restricted domain. So if I'm going to solve this, let me zoom up here. It's not going to help me really to change this into exponential form because I don't have a log on this side, right? This property, there's no log on that right-hand side, but my new property, my one-to-one property, I can use because even though it's not written, those are both log base 10s. So what can I do with these two things? Well, you just set them equal to each other. This is pretty simple, guys. And you solve. So I'd subtract the 2x over, I'd get 3x equals 9, or x equals 3. So this would be my solution as long as when I plug that in, either over on this side or over on this side, I do not get 0 or a negative number. So you can kind of do a little check here. If I plug in 3 here, I'm going to get log of 15. Is that good? Yeah, that's okay. What about over here? Log of, well, 2 times 3 is 6 plus 9. I also get 15. Surprise, it works. All right. So that works and we're good. What about over here? I have the same log base on both sides, so I set these equal to each other. So I get 10 minus 4x equals 10 minus 3x. Solve, I would subtract 10 from both sides. That gives me negative 4x equals negative 3x. I would add 4x to both sides. That gives me 0 equals x. So this is my answer as long as when you plug it in up here, you don't get 0 or a negative number. So if you notice you plug in here, that's just going to go away. I'd get log base 4 of 10, and that's okay. What about over here? You plug in 0, negative 3 times 0 goes away. I get log base 4 of 10 again, and that works. Alrighty, next problems. So this time I do not have another log on the other side. So the log is isolated, so I can go ahead and put this back into exponential to solve. So how do I do that? Well, the base here is 5 to the second power equals 2x plus 4. And then you just solve for your variable. So this is 25 equals 2x plus 4. Subtract 4 from both sides, I get 21 equals 2x. Divide by 2, I get x equals 21 over 2, which is the same as 10.5. I'm okay with either of these. And this will work as long as when you plug that in here, this whole thing doesn't become 0 or a negative number, and it's good. So you move on. What about this one? So the difference here is there was only a 1 out front, technically. Like if you had to put a number there, there'd just be a 1. But this time there's a negative out front. So instead of making that a power, using the power property, we can just divide both sides by any number multiplied, as long as you do it to the other side as well. That gives me log base 7 of negative 2r equals 0. Then change it to exponential. So 7 to the 0 equals negative 2r. What's any number to the 0 power is 1. And divide, you get r equals negative 1/2. Now, this is my answer as long as when I plug it in here, I don't get a negative number and or 0, right? It actually works because a negative times a negative will end up being positive numbers. So it works and you're not going to get 0 there. So next ones. Very similarly, like number 4, there was a number out front of the log. And number 5, there's not a number out front, but there's a number added, technically subtracted, the negative 10. So you want to get that to the other side, just like you got the negative 2 technically to the other side by dividing. So we would add 10 to the other side using inverse operations. Those cancel. I get log base 3 of n plus 3 equals 0. Now change it to exponential. 3 to the 0 equals n plus 3. So on and so forth here, guys. So we get 1 equals n plus 3, or n equals negative 2. This is your answer as long as when you plug it in to your log, you don't get 0 or a negative number. So even though it's negative, think about this, you'd have negative 2 plus 3. That still gives you log base 3 of 1. So you're still good, and it's not 0. Over here, so now that I have logs on both sides again, I can kind of go back to my new property and set those equal to each other. X equals x squared minus 2. Now we have a quadratic. So how do we solve quadratics, right? Well, we get one side equal to 0. Where did this minus x come from? Do you guys see? I just subtract x from this side. I'd subtract x from this side, and then I rearranged. So how do I solve that? Well, you can use your factoring techniques. This factors to x minus 2, x plus 1. Use your 0 product property, and you get x equals 2 and x equals negative 1. So we actually have 2 answers here as long as both of them, when you plug them in for this x and this x here, do not give you 0 or negative. So the 2, let's try the 2 out first. Log base 3 of 2, that's okay. Log base 3 of 2 squared is 4 minus 2, that's 2. So that one works. What about the -1? Log base 3 of -1. Do you see you immediately have an issue, even if it works on the right-hand side, which it doesn't. But if it gives you a negative at any point, this is not a solution. And these are called, the fancy word of saying this is an extraneous solution. All right, it's basically a solution that looks like it's going to work, but actually is in the restricted domain. Alrighty, day 3 is done now, so work on your homework. Remember to check those domain restrictions.